Sketch the graph of the polar equation r equals 4 cosine theta plus 2 sine theta. What I'm going to do here as a starting point is make a table of values. At the end of the podcast, I'll also do this algebraically so we can see what the shape is from a different perspective. But let's start with a table of values. I'm going to make a table that includes an angle theta. I'll have an angle or a value for 4 cosine theta and a value for 2 times the sine of theta, and finally a value for r, which will be the sum of those previous two columns. If theta is 0, cosine is 1, so we have 4 here and 0 here because sine is 0, and that gives me our value of 4 when I'm pointing in the 0 radian direction. If we go to pi over 6, cosine is root 3 over 2, and we have 4 times root 3 over 2. That's 2 root 3. Sine of pi over 6 is 1/2, and 2 times 1/2 is 1. And so r is the sum of those two columns. If I add this to this, I get the third column. And if we do that, I'll write a decimal approximation for r here. I get 4.5 or so. If we go to a pi over 3 radian angle, that's this direction, we'll have a cosine equal to 1/2, so 4 times 1/2 is 2. Sine will equal root 3 over 2, and when I multiply by 2, I just get root 3. Adding those gives me the r value I need, and 2 plus root 3 is approximately 3.7. If I go to pi over 2, I have 4 times nothing. Cosine of pi over 2 is 0. Sine is 1, so I get 2 times 1 for 2 here, for a value of 2 for the r value. Let's plot what we have so far. In the 0 degree or 0 radian direction, we had to go 4 units. So 1, 2, 3, 4. In the pi over 6 direction, we had to go 4.5. Notice I'm using every other circle, concentric circle here as 1 unit. That's my scale. If I go in the pi over 3 direction, I need to go 1, 2, 3.7 out here. If I go in the pi over 2 direction straight up, I have to go 2 units. Let's see how the rest of this graph shapes up by plotting a few additional points. We put in 2 pi over 3, pointing along this direction. We have 4 times the cosine of 2 pi over 3, which is 4 times negative root 3 over 2. Oops, I'm sorry, that's negative 1/2. So we get a value of negative 2 there. The sine of 2 pi over 3 will be the same as the sine of pi over 3, and when I double that, I'll just get root 3. And the sum of those two is approximately negative 0.3. If I go to 5 pi over 6, the next angle marked on my polar grid paper, I have 4 times, let's see, this cosine will be root 3 over 2, negative root 3 over 2, and so I'm going to have negative 2 root 3 here. Sine of 5 pi over 6 is 1/2, and 2 of those makes just 1, which gives me a decimal value of approximately negative 2.5. Let's do one more. We go to pi. Cosine of pi is negative 1, so we have negative 4. Sine of pi is 0, so doubling that gives me 0, and adding gives me negative 4. Let's plot those points. If I look in the 2 pi over 3 direction, I have to go back 0.3 units. That gets me to about right here. If I look in the 5 pi over 6 direction, I need to go back 2.5 units, 1, 2.5. And if I look in the pi direction, I have to go back 4 units. That gets me back to this point. Looks as though we've traced out a circle. In the plane with the points that we've plotted. We could confirm that algebraically by using the relationships between polar and Cartesian coordinate systems. I'll do that here and just pop up the solution so you can look at it if you like. Notice what I've done here is taken the original equation and multiplied through by r. Now I've made the substitutions for converting to Cartesian. Now we have a Cartesian equation. We just need to complete the square to find the equation of a circle. And there we have it.